For the newly joined participants, I'd like to introduce Professor Ravi Shanker garu. So in this regard, I request our Madam Gayatri Madam to have a brief introduction about Dr. Ravi Shanker garu. Madam.
Good afternoon, everyone. I'm Gayatri from Civil Department in working as an assistant professor in Sri Venkateswara College of Engineering. Today, I would like to tell about a few words about Dr. KVR Ravi Shanker garu. Dr. KVR Ravi Shanker garu had completed his PhD in Civil Engineering, Indian Institute of Technology, Bombay, and he had completed his MTech Transportation Engineering JNTU, Hyderabad in 2004. He had completed his BTech in Kakatiya University, Warangal in 2002. Dr. Ravi Shanker garu has 10 years of teaching and research experience and presently working as an assistant professor in National Institute of Technology, Warangal, Telangana from April 2012. He has some research interests like pedestrian behavioral analysis and modeling, crowd dynamic analysis, and emergency evacuation planning, safety analysis of vehicular interactions in mixed traffic conditions, non-lane based behavior modeling, and nanoscopic model development, etc. He has completed some academic projects who he has guided for PhD 4 and for MTech 39 projects he has guided. Dr. Ravi Shanker garu has published 60 papers. In that, 26 were international journals and 28 were international conferences and 6 national conferences and 1 magazine and 1 book chapters. And he has some research development projects like pedestrian behavior dynamic analysis near intersections and terminals, DSC fast track project for young scientists in Government of India, New Delhi in 2014 to 17. He has major consultancy projects like he worked in the major consultancy projects as coordinator comprehensive traffic study plans of the cities of Karimnagar, Siddipet, Tirupati in 2012 to 2018 and the traffic signals and road marking strategy of the cities of Vijayawada, Andhra Pradesh and Ludhiana, Punjab 2013. He worked as a reviewer for Transportation Letters, International Journals of Transportation Research, and he worked as editorial board member, Trends in Transportation Engineering and Applications. He has invited lectures, 10 invited lectures, and he is a member and board of studies for civil engineering, Sri Vishnu Engineering College for Women in Bhimavaram from 2015 to 18. He has a life membership of Indian Road Congress and Institute of Urban Transportation India. He completed his he has educating road users on road safety as a part of Forum of Road Safety. Thank you, sir.
Good afternoon, Ravi Shanker garu. Thank you, sir, for accepting our invitation.
Hello, my voice is clear to all of you?
Yes, yes. We are able to do.
Okay. Okay. So then shall I start then?
Yes, sir.
Okay. Let me please can you allow me to share the screen? I think that option is not there.
Yeah, 1 minute, sir.
Okay.
Done, sir.
Yeah, okay, fine.
Check once, sir.
Yeah. So now I think you're able to
Yes.
see the screen. Okay, fine.
Yes, sir. Yes, sir.
Okay, thank you, Monanda. And good
Okay,
afternoon
sir.
to all.
Thank
So
you,
this
sir.
is fine.
Fine, sir. Fine, fine.
Okay, fine. Yeah, now mostly the last day of your FTP program. Also, thank you once again for giving me this opportunity. And this presentation is meant for the ITS intelligent transport systems. How best we can utilize them for the mobility of the particularly urban roads and safety improvement. That is the purpose for which this particular presentation has been made. And let us explore, let us discuss a little more in detail about how effectively the ITS intelligent transport systems can be best utilized. So this is my overview of my presentation. We'll just understand what is ITS. Maybe you are very well. Some of you might be aware about this. What is ITS? Anyway, for the rest of the participants, we'll have a small introduction. And then the future of mobility and what are the driving factors and the scale and what are the various types of ITS user services, particularly ATMS, transportation management systems, and area traffic control systems. Particularly, we'll discuss with one case study the coordination and how to integrate the modes and at some safety levels. Towards the second part of the presentation, we'll discuss about the advanced vehicle controls, then electronic stability control, and also towards the end of the presentation, we'll have a small discussion on the pedestrian safety. So that is the plan, my plan. So when you come to the intelligent transport system, so there are many other definitions are there, but the most simple one which I found is it is the use of some modern electronics or communication technology to improve the performance of the transportation system. So here more of a electronics components and the communication components will come into picture, but the end point will be taken care by the transportation engineer in terms of measuring the traffic characteristics or some kind of evaluating the performance of the system and making some changes. So that have to be taken care by. Even though the backbone is given by the electronics and CSE people, but it is basically the transportation professionals who have to take care about this aspect. That is one kind of definition. Then something other definitions go something similar to that. Some kind of efforts to add information and communication technology to transport infrastructure and vehicles to reduce the wear and tear and to reduce the travel time, etc. There is another thing, another interesting thing also, where it will say about what is the intelligent part of it. So it is something like defined as collection of some entities that collaborate in the movement of passengers or freight and which have the ability to learn. So here the catch is here that the intelligence comes in terms of the ability to learn and adapt to the new situations, and it is at the same time it has to update its knowledge to enhance the operational efficiency. Suppose you are doing some kind of a coordination and you want to optimize the travel time, then in that case you have to rely on the real travel time measurements, real time travel time measurements, and update the your algorithm in such a way that the delay is reduced. That is what the intelligent part of this covers about. Then transportation is regarding the movement of passengers and freight in the most simple terms. Then comes the system which collects the various data from the data collection devices, traffic data collection devices, and perform the tasks according to some kind of a regulations. Here the algorithms and these things will come into picture, and basically the entire system works on a common objective in terms of some for example, reducing the travel time or reducing the delays, something like that. This is what beautiful definition of ITS in one term we can call it as. Now coming to how the mobility is going to be, so as per this resource from the Federal Highway Administration, so it is one aspect is the convenience and efficiency of the transportation system as a whole, and the other side is the environmental benefits that are occurred that are going to occur because of this. So very beautifully they have given the various aspects involved in this. The first thing is some kind of aspects in terms of integrated trip information for different types of modes. For example, if you take best case is your Hyderabad city, wherein you have right now the MMTS is there, metro is there, existing bus transport is there. So the transfer time, the waiting time, the integration. Of course, we are also going to see one case study as a part of this presentation. So that is the integrated information. Then integrated payment sources, so like a single card, a single payment system. Then with lesser delay and reduce the delays between the modes in terms of waiting times or transfer times, and interconnectivity between the various carriers or the modes of transport. That is where the convenience and efficiency will come into the picture, and reducing dependence on the single occupancy travel mode. So that is environmental benefit. So always encouraging the group travel. Of course, now as the nowadays situation something different. That is a different question. Then some other connected vehicle services is still under development, and it is at a higher level. So this is the mobility patterns that are going to be in the future. Then if you look at the what kind of a knowledge we have and what kind of a traffic management we can do it. So if you look at this particular figure, so you can have some aspects in terms of like the more the knowledge, more better prediction may be possible, and more predicted when the traffic
Hello,
patterns are
sir.
much more. Hello.
Hello, slides are not moving, sir.
Anything wrong?
And your slides are not moving, sir. Slides.
Slides is not moving. I think that has occurred last time also. Now it is fine. Are you able to see the slides movement?
No, sir. No, sir.
Let me just. I'll just stop sharing and then again share it.
Okay, sir. Now it is visible, sir.
Now it is visible. Okay, 1 second. Let me. Yeah. Now, are you able to see the slide movement?
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
Okay, right. Yeah. If anything is wrong, even if my voice is not clear, please let me know. Okay.
Oh,
Then
okay.
this is what. And then this is what we are discussing about the so the from the reactive to the proactive states. So where in the reactive case we'll have less knowledge, or we don't have a real-time knowledge. We are based on some past information that is available with us, and we will do the traffic management. Whereas on the proactive side, we have some real-time information and more amount of knowledge is available, and which will go for a better prediction of these cases, and which will be able to guide in a better way, and better efficiency can be achieved. And coming to the driving factors behind this ITS systems. So if you look at the technology side, there are many elements that have come up in the recent past. We will have after a few slides, we'll have discuss about that. But there are some other institutional and organizational realities in terms of the coordination between the various agencies and in terms of the exchange of information or databases and etc. And there are some kind of other external factors also which may drive this ITS system. Then one more thing is at what level, at what time scale we can have this kind of a integration. So that depends on three types of scales we can divide. So one is the time scale where real time it is happening. Something like a signalized intersection is there, wherein in real time the traffic information or the delay is transformed to the traffic management center where the green time optimization and various other things can be managed. So that is some kind of a real-time coordination exercise. Then there is another kind of tactical planning. So you know that there is some other event is going to occur, some rally or something is there, or some kind of a emergency approach is required. Then in that case we need to depend on some kind of a a planning exercise and what to be done in case of we need to have some alternative. So that is one thing. One more aspect is in terms of the strategic planning, in terms of long range planning for a particular event next year or something like that. So that is on a time scale where it is in for a shorter period of interval or longer period of interval, and in real time or after some time. Then the other point is in terms of the geographical scale, maybe citywide or in a state or in a region or national wide or some kind of a region cases. So that depends on the geographical scale. Then organizational scale in terms of the different modes or intermodal and integrated supply chain in terms of the freight and all those things will come into picture. So that is in brief about the scales of operation and the driving factors behind that. So just before we go for some of the case studies and all those information, so let us just briefly list out the various applications of this ITS. So one and foremost is the bus information system. You might be seeing in Mumbai or Delhi or some other places where this kind of advanced bus information has been given near the bus stop or some other media like a website or some other things. That is the application of IT, one of the applications of ITS. Then the other one is some kind of a traffic management or public transit management. Then real-time information sharing for all the other applications. So then the other one is GPS, global positioning system, to track a particular vehicle types or group of vehicles, and some kind of giving a weather information systems or some kind of a parking management or some accident or incident management and some kind of emergency management in terms of some kind of a movement of ambulance or some other vehicles. Then nowadays we are here, you might be aware about FASTag, that is the electronic toll collection system and commercial vehicle application. So these are some of the various applications of the ITS. So let us explore what are the ITS services, what are the different types of ITS services, and what are the best examples in our country where it has been implemented. So that part will, whatever is possible in this short period of time, I will try to cover some of these services. And coming to this, we can divide them into majorly the 7 ITS user services. One is the Advanced Traffic Management System, and APTS, Advanced Public Transportation System, so wherein your mode integration and all those things will come into picture. Then ATIS, Advanced Traveler Information System, regarding the public transit traveler information, or if you want to move from one place to another place in a particular city, what are the options available, what are the modes available, how much time it will take. Even the Google is a part of this, so sometimes we'll search from one place to another place. And even now it has got some rail information and various other information. That is also a part of the ATS, we can treat it as. Then comes the advanced road transportation systems, in which the non-urban cases will come into picture, and the other one is the commercial vehicle operations. And the last two, but one is the advanced automated highway system, where the vehicle driverless cars and some kind of intelligent vehicle integration, then vehicle to vehicle communication will come into, but that is at a higher level, and that is still at a research stage, and that has a long way to go. And the last part of this user services is the archived data user services, ADUS, actually, which is a recent addition to this user services. Some of the standard references you will find only 6 services. So the last one is regarding the where we have so much amount of big data is there, so much of data is available, and we need a transformation or transformation of the data from one user to another user. For example, ATIS and ATMS. So when you are transferring and dealing with a lot of data sets, and we need to store a large amount of data, then this archive data user will come to picture, and that is the need for that, and some of the IT services will use this archive data user services. Okay, this is the in brief about the various types of ITS users. So just one by one, small examples we'll take up. So for example, in the UCA, they have some kind of active traffic management, wherein on the previous section, some kind of the main focus area is on some kind of some incident happened, and they want to manage the lane management they want to do, so that it won't result in some kind of a shock wave or a queue is being formed, and there are some kind of real-time information is obtained regarding the density levels or the occupancy levels or the speeds of the average speeds of the traffic levels. Once the incident happened, so this information will be sent to the server, and there is another some kind of a ramp or another highway is there which is going to meet here, and we can control the using some kind of a ramp metering or using your lane management. We can forewarn the travelers regarding this particular incident, and you can make them move in a very organized manner, so that there is no shockwave is formed, or even if it is in case it is formed, the queue is not very lengthy, and we can give advanced information regarding the accident ahead, reduce your speed, change your lanes, and we can give this kind of information, manage the traffic. This is what active traffic management in brief on a previous section will consist of. So that can be something like this. So they have something, the first signboard which speaks. So there is a collision ahead. If you go to the second signboard, so they are saying you just merge. So this rightmost lanes, please merge to the leftmost lanes, and you always use your left because the incident happened on this lanes. Yeah, then once you go to the side, so collision head is, and right two lanes are closed. So this lane is already closed, and if you are in this lane, please move, and the speed is also reduced to 45 kilometers. And then the fourth signboard, so this is very location, and where the two lanes have completely closed, and so we can well manage this, and after the incident also we need to give the traveler the information that we have proceeded, you have crossed the end of the reduced speed zone, and we can come back to your normal speed. So this is what some kind of a well planned gantry, having a gantry, and when you have this kind of active traffic regarding the incident and all those things. So then for this kind of applications, so what kind of a traffic detectors they are using. So some are using inductive loop detectors, some are using based on the microwave radar. This comes under the non-intrusive, whereas inductive loop will come under the intrusive detection. Then some surveillance. So if you look at the detector types, these are some of the widely used, starting from the inductive loop, most basic one and the most cost-effective one, to the most recent one, something like the video analytics and microwave, infrared, some acoustic based, then some more radar based, magnetic, reduce frequency, reduce the distance on the RFID. Then the well-known GPS location system. And nowadays, some people are trying for using a Bluetooth device on for this kind of traffic detection technologies. There are many other out there, but these are some of the quite popular. And coming to some nowadays, there is a strong inclination towards video data extraction and uses of video data. So here, when you are using some video data, definitely we need some processor or image processing or some something you have to do it to make it to extract the traffic in real time or whatever. So here I would like to introduce you to this particular of course it is not in real time, but traffic data extractor we can you can take up a video recording of entire section, section, and you can use traffic data extractor, which is completely open source. It was developed under a project at IIT Bombay. So where you can do the vehicle counting. Just to check up, I think my whatever I am showing on my screen is visible to all of you. Basically, because I changed from my slide to the other website. Like, someone can confirm. Hello. Hello.
Audible, sir.
Yeah, yeah, audible, but even my screen, whatever the traffic data extractor website of IIT Bombay, I think it is visible to all the participants.
Yes,
This
sir.
time. Okay, fine. This
Okay,
time confirming.
okay, sir.
Okay, fine. Okay, then so this traffic data extractor can be used for the vehicle counting and speed extraction and some kind of a trajectory extraction is also possible, but we need to give little more details regarding the angle of the camera and what length it is covering, and we need to calibrate it before being used. But the better we are careful in collecting the video data from a high-rise point, the more accuracy we will be getting it. So this is one quite useful tool for this kind of application. Coming back to, so there is another one I recently I came across, that is data from sky.com, but of course it is outside the country, which is basically some kind of a commercial version, but they have one good good option of some kind of with academic institutes. They want to collaborate and they want to have some kind of testing their own technologies. So that is this is for data from sky. We gave in for some sample applications. We can use their DFS view here, and we can get some information. So they have plenty of products are available, but the only thing is they won't give us the complete technology. We have to upload on their server so the video taken from the camera or the drone or some other things, and they will analyze this data and they will give you the required information regarding the traffic and maybe multiple cameras also they can deal with this. Okay, this is also one good another one I came across, but this is maybe if you are using for some kind of a non-academic or non-research purpose, it will be a little bit costly exercise. You can explore this also. Like this, many other options are also available. For example, if you go to some this kind of a extraction information, there are many research studies that have been taken up regarding vehicle tracking and speed estimation. So if you just explore the internet, some of those codes have been open source, and some of them have been. You can request the researchers; they provide the source code, and some are available even in MATLAB or the NIST processing. You can develop your own algorithm for extracting this kind of information. But that takes a little bit more time, and we need some kind of coding knowledge. But basically, this is nowadays people are searching for this kind of a tool that can be better utilized for extracting this kind of speed and traffic data information. So I'm just leaving it here. You can explore the various options that are available. But big data extraction is becoming quite popular, and even there are for nighttime vision capabilities are also they're getting into. Yeah, that is regarding the data extraction part from the ITS point of view. And nowadays, some people are using even drones also for collecting this kind of information. So that is a different story. Now coming to the one of our major topic of our discussion today, that is regarding the this area traffic control systems, advanced traffic management system, ATMs. So one major traffic challenge in majority of the cities, medium-sized cities, even not only the metro cities, is the problem with the signal coordination and the adaptive traffic signal control system. So how to optimize this flow levels and minimize the delays. So there are many studies have been done and many technologies have been developed. So that part is to have a small discussion in detail with one or two case studies in India, and which we have also conducted in the recent past. So that is in terms of some of the well-known concepts. You might be some of you might have heard about this called SCOOT and SCAT. SCOOT is from the UK. Is split cycle offset optimization technique. So that is one part, and the Australian-based SCAT, Sydney Coordinated Approach Traffic Systems. Then similarly, there are many other similar kind of things are there from some other countries, some other regions. Yeah, then one aspect in all this kind of arterial traffic signal uh, coordination exercise is basically we need some kind of a detector on the roadside, and which has to detect the road traffic information regarding and it has to be sent to the server, and server has to in turn communicate with the signal controller for giving some kind of priority or some kind of a coordination exercise. That is what basically, in simple terms, how this system will be used. So that is just like you have seen in the previous slides. So in the ATMS, we can use it for some kind of a dynamic lane user control or a dynamic speed limit or dynamic merge control, dynamic routing, or giving some kind of a queue warning, or some kind of arterial applications like some kind of a junction management and junction control, traffic signal control and coordination, priority, or some kind of a lane reversing also. We can do it depending on the traffic levels or morning peak or evening peak. Yeah, this kind of a management can be done. Once you have the setup, we can utilize those services for the various other applications. So that is uh, the big picture of this kind of applications. But we may not be able to achieve all this within a short period of time. We need some 5 years or 6 years to slowly adopt these situations, and your algorithm also should be in a position to adjust to the local conditions, and the personal operating person also should be qualified enough to manage with these things. Then only the larger applications can be had. We can better say. Yeah, but in simple terms, so what is basically a coordination, a signal coordination? So there are a group of signals are available in a city, okay, in a corridor. Then the most simple case, when you don't have any IT system or something, and you are working on a fixed type signal controller. So the first signal has some kind of a the green time and the red time, and the second signal has something else. And then basically, the offset is defined as the time difference between the starting of the green interval from the first intersection to the second intersection. This is what basic offset is. So the idea is here, by the time a platoon of vehicles which has cleared the first intersection, by the time it reaches the next intersection, maybe in another cycle or another 2-3 cycles, it has to get a green, and that green has to be continued throughout the entire corridor. So that is what basically. Then in the case of what is a vehicle actuated controller is, in terms of the green interval, so there is a possibility to extend the green depending on the demand. So for example, you take this particular example. So this is what the initial green is going to end somewhere here. But there is a possibility, depending on the particular line, a particular direction, the green extension can be is possible, and depending on the performance or the next number of cycles, so you can terminate the green, or you can still extend the green, but beyond certain limits there are. And once you change this green interval, so then your obviously your cycle time and the other green times are going to change. So that is different. So then your offset also is going to be changed, and basically we have a number of intersections. So if you look at the time space diagram, you will get something like this. So this is what. So if you look at this, there is a some extra delay of vehicles is there, or queue is formed. So I want to extend some extra green I want to introduce, so that the more number of vehicles can be cleared. But at the same time, keeping some cap on the maximum green interval and the maximum cycle time, as per the code of practice, or as per the operational difficulty, whatever it is. But basically, it may not be possible to continuously get over a number of intersections a completely green band. That is what the other term offset and bandwidth. So offset is the green time difference, and the bandwidth is the time difference between continuous green interval that is possible throughout a section of the corridor. Then regarding this, there is in simple term regarding the coordination level. So coming to the comparison between the SVCET of the UK and the SCAT of the Australia. So in terms of the detection placement, upstream or downstream detection, so there are some differences are there. And in terms of centralized or distributed system, wherein SVCET, each signal controller will act as like something like one controller itself, whereas SCAT is not like that, and it is SVCET operates on some kind of a fallback fixed mode, and it is on SCAT is on the vehicle entity mode, and this SVCET is on model based, and SCAT is okay. That is some kind of a difference that you can get it. So now coming to this coordination on a corridor. So let me just check with one of our case studies which we have done very recently. So this is these are some of the major 7 junctions in Karimnagar. Some are 4 legs, some are 3 legs, and we want to have using a victim simulation tool. We wish to achieve some kind of a coordination on this corridor. So basically, if you look at the kind of challenge, the distance between these intersections is quite something quite different to compare the distance between. So that is quite challenging exercise. But that is true. So these are the corridor, entire corridor is not only a straight one, there are many other. And this is one of the intersections. Why I specifically mentioning about this particular intersection is the geometry is something not a regular geometry of a four-legged intersection. It has got some kind of a typical geometry, and we need to take into consideration the kind of a geometry also when we are coordinating. Because if you simply theoretically you may be thinking about, okay, it is some kind of four-legged intersection with a normal traffic movement level, so then the traffic can be moved within the green time interval. You are expecting some capacity of them, let us say 100 vehicles will be able to clear within a time period of the green time interval, but actually that may not happen because of the geometry. Your whatever the saturation floor, whatever you are going to say for a per lane width, it may not be really practically may not be possible. In those cases, your calculations may go wrong, and you may have some kind of a difficulty in coordinating the entire corridor. So that has to be taken care. And the other point in challenge in this point, this kind of a coordination exercise is the vehicle composition. So if you look at this particular, the number of two-wheelers are 65%, so more than 50%, and that plays a role in terms of the coordination exercise. So that better I can just show you. So we have done some kind of a simulation of this corridor, like a corridor in Visim, and we have done some routing exercise or calibration of this. So and one more point I would like to stress is whenever you are using any kind of a microscopic simulation tool, you have to be very careful in calibrating it. Without calibration, you come out with some results. They are not going to be realistic or close to your real field conditions. So that is another challenge we'll be facing when you are using some simulation tool. So just we have done some exercise of coordinating. I won't give you because of the shortage of time. I have to discuss some other points. So just I would like to stress upon what is happening after the coordination. So with coordination and without coordination, yeah, there is some kind of the travel time differences. So with coordination, there is a reduction of travel time. That is one aspect which is quite interesting, and that is for the upstream, and similarly for the downstream also. That is two-way coordination basically. This is quite very difficult practically speaking. So the two-way coordination is also tried, and except for the first two intersections, it seems to be working well, at least for the from the simulation point of view. But this is not really tested on the field. We have to quite see, but we have done very simple coordination in terms of the coordination between the optimizing the offset and the bandwidth, nothing more than that. Yeah. Then coming to this, this is what from the same simulation exercise. So the blue line is the one way of coordination, and that side, the two-way coordination is the other side is the green one. So these two have been tried and implemented on a time distance diagram. Everything looks good and beautiful on the paper or on the slide, but when you do this on a larger scale and implement it in the field, then the real problems will come into picture. The real challenge is going to come into picture. And then so I would like to stress, so I'm saying about the vehicle composition. So here you take the bike or the two-wheelers. So if you, sorry, if you, if you take the two-wheeler composition levels, so then as the composition is increased from 65% to more than that, and how the travel time is going to, if only two-wheelers are there, entirely the entire things are occupied by the two-wheelers, not by the other things, then how the travel time is going to reduce because of their maneuverability or whatever it is. So basically, what I would like to stress upon here is when you are calculating some, when you are doing some coordination exercise, and you are calculating some based on some our Webster's formula or HCM, whatever it is, the signal timings and then the corresponding offsets and bandwidths. Basically, what happens is we need to assume some kind of a operating speed of the entire traffic stream. So that entire stream is operating at some is traveling at 30 kilometers per 40 kilometers per hour, but it is not true for all the vehicle types. It may be true for a passenger car, but a two-wheeler or a three-wheeler or some other bus or something may be traveling at a different speed, and that will make your calculations go wrong. So as you can see in this from the simulation exercise, whatever we have done it, so definitely the vehicle composition has an effect on the travel time and thereby the in terms of reducing the delay and all those things. So regarding this, I would like to give you some more examples. Just one second, I'll just show you. So other than this, whatever we have done using this thing, there are nowadays other than Scoot and SCAT. So regarding the area traffic control system, so there are some other things have been tried. But before we go, just how a coordination exercise basically works, you can just better experience it. You can visualize it through this video. So there are two intersections. Yeah, I suppose this video is visible to all the participants. If it is not visible, please let me know. This is the intersection, two intersections, intersection 465 and 466. Okay, and then without coordination is off. Coordination is on. You just see how the delays are happening. Please kind of closely observe the vehicular stoppages, delays, or the queues that are found. Now that coordination is off, there is a queue is found. Yeah, so almost every cycle has some number of cycles are in queue and the coordination is not planned. Now, after some period of time, they have, as per some algorithm or some calculations, they have done the coordination exercise. Let us see what happens to the coordination. Yeah, now the coordination is on. You can just see how dynamically the things will change and whether there is a lesser delay there or not. Yeah, whenever on your right side, whatever the leg is that is available, so if you signal controller is not observing any kind of a vehicular traffic, simply it is terminated and the green is given to the other intersection where more traffic is available. Then once some queue is built up on this, they have used the loop detector. Once the queue is to clear the once the other side is somewhat free, then immediately this queue is cleared. Yeah. So hardly you are finding some 2 or 3 vehicles standing. Okay, this is also clear. Almost no queues are also. Yeah. So this is how basically a coordination exercise should control. So once the other side is free, then this will be resolved well. So based on the vehicular demand levels, the vehicle accelerator controller is working, and there is this is one of the applications of this kind of thing. Okay, now let us come to another real field case study done by the Center for Development of Advanced Computing, CDAC, Thiruvananthapuram. So they have, so I'm thankful to them for sharing their knowledge with us some time back when we attended some, when I attended some workshop of the related to ITS at CDAC Trivandrum. So that part that I would like to share with you all regarding this area traffic control system. So I'll not go into the much more details. Maybe you can get this kind of information from their website also. So basically, what kind of a major building blocks they are also using some kind of loop detectors, but only the kind of a difference in terms of the detectors is the detector placement is there is a difference is there what these people are trying. Yeah, then basically I told you about the SCOOT and SCAT systems, some of the popular operational models for this kind of a advanced area traffic control system exercise. Now, what the CDAC people are suggesting is a COSI course, Composite Signal Control Strategy. So, what is this COSI course? To briefly, I would like to touch in this particular. So, basically, this is a SCOOT model, a centralized model where there is a from the loop detector, the information is regarding the queues or the in a particular phase is given, and the optimizer, central optimizer or the offset optimizer will calculate the offset and bandwidth values. Then the cycle optimizer will be there, and over a number of cycles it will be analyzed from the performance point of view, and that in turn will go to your so once the traffic information is reached here, the demand, so it will the optimization and everything will go, and the transition plan will go to the signal controller, and which in turn will again communicate to the regarding their next queues and all. This is what COOT. So whereas a SCAT will work on some kind of a, so you have some kind of a regions, and in each region, so there is some kind of a command control kind of a thing is there. This is what region based, and the other one, the major difference between SCOOT and CAT. And you have the other things in terms of the SCOOT and other things will work. So the major difference, what our people are for our Indian traffic conditions, so they want to give some kind of a optimization at a different level. So they are interested in terms of analyzing the using some kind of a performance index, and in addition to the regular offset optimizers and split optimizers, so we need some kind of area optimizer for the entire corridor, and based on the area optimizer, so the performance index is calculated, and that in turn will give you based on the current cost timings, and that plan will be communicated to the junction controller, and this cycle will go on. So there are some similarities and some differences in terms of the operational capabilities of this course. This is what they're trying that some kind of a synchronized portion and all this. Yeah. So the major challenge is In our country, in our countries like Indian traffic conditions are of the vehicles and the limited lane discipline. So it also have which we speak kind of for vehicles. So we have our basic HCM kind of a signal time computation. So even they are not much optimized. We generally will use the passenger car unit PCU, but how far it will be really representative of the traffic conditions is still question mark. And this is what in brief about the difference between Scoot, SCAT, and Coast. So the scalability levels are in terms of the model based and in terms of the calibration issues also. The Coast they are promising it is promising to be much more better than the other two systems. Yeah, then they have done with simple signal time generation. Basic, I just tell you 1 second. This is what the detector placement. So we have, if you observe it any signal controller, so generally we'll come across something like this kind of a position. Some of the vehicles will come forward and take a right turn, something like that. So they have players for this kind of a measuring the right turning traffic like in another detector and this place. So that is what one major difference in terms of the detector placement. So the through traffic and the right turning traffic has to be clearly measured. And this kind of a then once this kind of information is available, then the cost philosophy will come into picture where the offset and based on the cycle length, so the offset and the split time will be created at each intersection and at the coordinate and for the picture, which will give you some details regarding the optimizers. So, and finally, the performance index will be calculated based on the utilized grain interval measured and computed during the every transition. So based on that one, the allocation of the extra grain to the other intersections will be all and this kind of a split optimizer and offset optimizer will hand in hand and whatever the based on the action of required and the new offset will be transmitted to the signal controller and there are some kind of corrections. I am not going into the all details about these things, but basically this is how their method of coordination will work in terms of the split optimization, area optimization, and the offset optimizer. And this kind of a distributed system with has got its own advantages. And this coast has been implemented in India, in Pune, Jaipur, and Ahmedabad, and Kolkata, and many other places some time back actually. And at many intersections, they were saying that. So maybe if you are interested, you can consult the Ravi Kumar from the feedback for more details about this kind of systems. But so the real challenge in terms of this kind of things is we just see this. Yeah, just see this thing. This is one of the signalized intersection in Singapore, where you can see the kind of traffic movement, what is basically lane-based traffic, how it is moving. Yeah. And if you regards to the composition levels also, most of the traffic is in terms of the passenger cars only, not much, not many other vehicles take for available. This is the situation in but whereas if you take the case of kind of you might have seen the same in other presentation. So this is also signalized intersection with so many vehicle types and a lot of pedestrian movement is you want to coordinate the signals. This is where I'm saying about they'll place the so this kind of right turning vehicles are there. They're coming and taking. So they are placing a detector here. That is suit our kind of Indian mixed traffic conditions. The detector placement and the effect of this kind of pedestrians or effect of vehicle composition on the coordination efficiency is a very good research topic nowadays. Then these are some of the examples. Then there is also another one like Hyderabad traffic integrated systems that also has been tried some time back, and the other point is mode integration. That I'll try to cover a little bit with another case study which we have done in for the Hyderabad city. But just before that, so whatever the ATMS and the ATA, so they share some common points, and there is a interlocking between the ATMS and the ATAS in terms of the information sharing, in terms of the estimating the network state levels and giving the travelers regarding this the queues or blockages that are happening at a particular intersection or a section of the highway to the ATS travelers in terms of the updating the dynamic information from the field in real time. Then the ATS in turn will give some kind of a, they'll change their tactics and they'll choose another route or another mode, and how this in turn will affect our traffic management system. So these two will go in hand. Then only the real ITS benefits can be we can see overall. So regarding this, before I go for the other case study regarding the integration of the modes, that I would like to stress upon some of the research topics can be something like the influence of vehicle composition, just like what we did in simulation, or the operating speed on the signal coordination efficiency, and development of some kind of optimized algorithms and use of simulation tools, microscopic or microscopic, urban arterial coordinations, and how challenging it will be for mixed traffic conditions. And the other topics are something like determination of mode shift on the urban corridors. So introduction of a metro, how it is going to change the urban travel patterns, and integration of this multimodal planning of urban transport system. So these are some of the very highly potential research topics that can be planned as a part of this kind of traffic information analysis. Yeah, now coming to the this other study, just let me have a small a quick presentation on this integration of the modes in Hyderabad analysis in Hyderabad using the vision simulation tool. So here this is one of our past MTech students, another faculty. Basically, what we have done is here in this particular research study is we want to evaluate the existing bus network by means of calculating the accessibility and the travel time across the and what kind of a transfer time, waiting times are available. So we collected some information, and we at that time actually the metro is not happening. This is done some few years back, and metro was not operational. So we assumed some kind of a stoppages on the metro network. Then we suggested some improvements to the existing bus network for enhanced integration of the modes. That is the main objective of this kind of a study. Then we collected some information and identifying the deficiencies. This is the study area that is collected, a part of the Hyderabad city in terms of covering the major corridors of size 39 square kilometers, and there are some highway, urban major highways are also crossing urban corridors. Yeah. Then we collected data regarding the bus stops and their coordinates and what are the bus depots available, what is the run time between the bus stops in the corridor, bus stop information, line route information, timetable of the bus stop, and some data regarding the OD, passenger OD data also was collected. Then a detailed network modeling is done in this network, microscopic one, where the links, various links and the zones and the timetable is fed into the complete network. And these are the various stops that are available. Total of 97 bus stop locations in the selected study area, where 55 zones are available. Then these are the line routes, 54 line routes. This is the time graphical timetable that has been fed based on the existing data. Then based on the body pattern that are observed in the on the field, so a demand modeling is done in this, and then we want to estimate in terms of what the demand is going to change once we have particular a shift from one mode to another mode. Definitely tried in this kind of exercise. Then this kind of indicators, basically we are more interested in terms of calculating the transfer times, but at the same time we can also do with access times and waiting times also. It is quite possible for comparing these things. Then we analyzed the existing bus network in terms of how many number of service trips it is making, how many passenger volumes are there, and what is the accessibility of these bus stops to the nearby, and what are the transfer waiting times, and link evaluation is also done. So then based on the statistics that we got it, so this is what bus stop accessibility, that is something like a catchment area. So you see some kind of dots, so that whatever the blue region that is there, so it is hardly something like when you can walk up to some kind of a 250 or 300 meters to reach a particular bus stop. And more than that will not be, people may not be much interested in opting for the bus transit, and they'll go for some kind of private transport mode. But at the same time, if you provide a proper parking facility, that may be a different question. What the challenge even Hyderabad Metro is also facing in terms of the availability of parking places at all the metro stops. Then some kind of isochrones representing the travel times in minutes, referring to some kind of a certain important points or bus stops along the network. So this will give you some kind of information on your accessibility and transfer waiting times near the Secunderabad railway station and the Koti and all. And some deficiencies have been observed. So there are some areas are not served by bus stops. For example, if you just take this the previous case, so there are many gaps are available in these places wherein the service has to be covered by this bus stops. So either we need to increase the number of bus stops or increase the routing schedule, or rerouting the schedules. Then or we can plan for another corridor. So this kind of evaluation can be done, and we suggested some things, and areas not served by the bus stops were identified basically, and these portions. Then some new bus stops have been suggested by finding the deficiencies in the network coverage. Okay. A more better operational efficient public transit network. Then one more thing is the transfer waiting time, particularly near the Secunderabad and all those things. So that also has been tried, and we have done with some kind of a shifting of some existing bus stops, shifting of some bus journeys, establishment of new line routes, and there is a proposed metro line is also there at that time. So the metro line is also introduced, and metro line 1, 2 introduced, which are passing through this our corridor. Then impact of this kind of options are also suggested. The stop accessibility and the impact on the travel time, Then the line network coverage. So compared to the previous one, you can clearly see that we are catering to much more area of this kind of study area. So these kind of things are possible once you have a database is set up and you have the complete information uh, regarding the corridor and regarding the services that are available and how best we can utilize these kind of tools for enhancing the efficient public transport systems and the integration of this. So when you say integration, even though I have not specified here particularly, so we can say in terms of another study also can be done in terms of identifying the potential drawbacks in the existing systems. And when you are saying about integration, it is not simply the physical integration between the bus stops and the metro stations. It is also the operational integration. It is not only timetable integration. It is the operational integration that will matter a lot in the urban travel patterns. When your operational integration is there and the waiting times are very less and your transfer times are much more convenient, then we can say something like more number of people can be from the private transport to the public transport, and even in terms of the health of the individuals also there is a lot of improvement. But of course nowadays the situations available in roads and public transport, how it is going to affect is a different question to be answered. Okay, so this is about the mobility point of view. Maybe I'll take another 10 minutes and we'll wind up. I'll try to wind up. So the other part of my presentation is the how the road safety can be improved using ITS. How the intelligence systems will be more effective in reducing the crashes. Yeah, you might have heard about something called ABS, which is quite there in some of the four-wheelers and even two-wheelers also speaking about it. Yeah, then anti-lock braking system, so that is quite widely used, but nowadays people are speaking about electronic stability control and advanced vehicle control. So not much I could get it wherein we have done a lot of work regarding the IT applications in safety, but definitely some this is particularly this is in wherein they have done a lot of studies on that. You can leisurely go through this website and see about what they are doing. So, some kind of active safety control in automotive cyber physical systems. So they have done some experimental setup and driver monitoring is done. There is speed camera accuracy, motion capture is there. They are doing the experimental the real time driving utilize the this kind of studies for the development of advanced vehicle control system, where even the human errors can be minimized and the system can take care about the our aspects. So this is what going on at a higher level regarding the applications of this prediction of some kind of a driver behavior is also tried. Driver is basically when he is attending to a call, so how the driving behavior change. That is also being tried in this particular experiment. Yeah, then similarly the kind of a regarding some kind of testing with autonomous. What kind of experiments they are doing in the real field. So kind of scientist, driver assistant system. So basically, whenever that lane departure avoidance, so they want to predict the lane departure from one lane to another lane. The driver is changing. So they are trying to come out with some advanced vehicle control system regarding this. This is some of the interesting things that are happening, and I mean similarly you have some kind of advanced vehicle control. So that is coming to the other one. I was saying about electronic stability control. So this is regarding. And so whenever a vehicle is there, particularly a truck or something, with a lot of different dimensions, so how the stability of the vehicle can be guaranteed, and so that is what the electronic stability control is not. Yeah, so that is what about the without the electronic stability control and with the ESC. There are many other studies have been are going on regarding the development of driverless cars and how vehicle to the infrastructure integration, vehicle to vehicle integration. But in this aspect, our country has to go a long way, and literally speaking, we need to do a lot in this direction. Yeah, well, the last part of my just another 3 minutes and this close is the most important aspect of how the pedestrian safety is guaranteed. So I came across something like some people, so smart LED crossing in London, and another one is smart pedestrian signal in Dubai, I think. And there is one more is there pedestrian airbag study by Volvo. Yeah, this I'll just show you those things. I'll just yeah, this is the Dubai and smart pedestrian traffic signal. Basically, it is something like it is just giving the pedestrians along the the zebra crossing is there, that it is some kind of a green or red is available, and how it's a very simple level. Similarly, you can also see the smart LED crossing in London, and there is also one more by Volvo regarding pedestrian airbag. We will just close the there is also in some experimental stage. So whenever a pedestrian is hit by a vehicle, so just like our inside the car vehicle, like airbags were there, in similar fashion, the airbags will come in the front of the vehicle, and the pedestrian life can be saved. So this is what a pedestrian airbag is. Yes. But I'll just show you one interesting video. Hollywood intersection, and just without any kind of inducement. So this is how it is. So a lot of pedestrian movement and or regular pedestrian crossing is there. But what they have done is, I think, they introduced a scramble crosswalk and see what is happening. So unlike just like so not much intelligence is required, a simple using a scramble crosswalk, like a diagonal crosswalk. Things to be something different for the pedestrian safety. So even that is what I used to say to many of my students that whenever we are introducing something, like we are speaking a lot about the ITF and all these aspects for the travel time savings and increased capacity and enhancement of the operational efficiency and reducing the crashes and fatalities. So basically, when you say these ITF benefits are, so we need to quantify them. So that is also a major task. And one more point is all this is artificial intelligence, and the clash between the artificial and the human intelligence will always be there. And I'm not saying something against the artificial intelligence, but when we use the artificial intelligence using the human intelligence in the most possible way, then only we can get the most out of most benefit out of it. Otherwise, it is not going to be a beneficial one, and we can't optimize. We may not be able to optimize the benefits. That is the last point I would like to stress upon. And with due credits to all my students who are involved in some of our studies and faculty colleagues. And also I tried to cite some various resources which I have used in this presentation, but you can by mistake when any uncited resource is there from any researchers, I would like to credit those things. So thanks a lot for the kind attention, and you can always mail me, and you can also, if in case wherever you may be working as a part of your work or some thesis work or something. So in case you come across any doubt, any kind of you want to collaborate with NIT Warangal or our team regarding some kind of a research problem, so definitely we would like to extend our cooperation, and please drop a mail, and we will try to respond in the minimum possible time. And if it is our ideas are matching, definitely we can work together some common objective. This is what I have to share with all of you. Maybe I thought it is something interesting to all of you. Now I leave my session, and if any questions are there, we can take a couple of questions.
For your elaborative and very interesting presentation on ITS. particularly in the current scenario of transportation engine, controlling manually the traffic and regulation, everything is getting very difficult nowadays. And with the support of these ITs, definitely we can regulate the traffic and the safety elements also can improve. Thank you for giving more details on the ITs and the traffic scenario. And yes. So on this occasion, I'd like to ask the participants, please share your questions. Please share questions and we'd like to ask them the questions so that we can. Yes. Unmute your mic, please. Any questions?
Hello. Hello, sir.
Please tell me.
One question here. Archive data user services means what? That one? Actually, use of that one?
Yeah, that is actually whenever we are doing this ITS kind of things, we need to get a lot of amount of data. So much data will be available, and for example, you take the simple case of a coordination. Let us say you have 10 intersections are there in a city.
Okay.
For example, so we need to get every day. You have to count the number of vehicles and you have to store them, and at least 1 week. You have to do analysis in terms of for the entire week during what period of time the congestion happened, how much queue was there, which intersection is badly performing.
Okay.
You need to do all this data, and that data also will be used only for the not only for the coordination. That will be used for traveler information system of the ATIS. So when you are dealing with this kind of a large amount of data, so we need to the storage of this kind of a data and transformation and information exchange of this kind of a data. So ATS people, ATS application may not need this entire data. It needs only a part of the data.
Okay.
So that archive data user services will do this exercise. So
Yes,
that will
sir.
take care about the collection of the data, storage and dissemination and all.
Good, sir. I am Dr. Murthy from Hyderabad.
Okay, sir. Okay, where are you working?
Here in CMR College.
CMR. Okay, fine. Okay.
CMR. Sir, another one. Freeway ATM. What is that? Freeway ATM.
Okay, freeway active traffic management. So there, suppose on some incident happened on a freeway.
Yes, sir.
Then we need some technology to detect that incident and inform the travelers maybe 3 kilometers or 5 kilometers ahead of that, and
Yes,
so that the vehicles can slow down and change the lanes without affecting the normal flow of the traffic.
Yes, sir.
That is about the freeway active traffic.
Sir, another one, sir. Here, pedestrian airbag.
Yeah.
Pedestrian airbags. Now,
Right.
these are useful for in Hyderabad also.
Actually, they are in the experimental stage. Volvo is trying for that pedestrian airbags, but basically, that is, I suppose, when you are speaking about driverless cars.
Yes,
So
sir.
they need this kind of airbags and all these things, because by chance, if anything is hit, if any driverless car hits that,
Yes, sir.
then the safety of the pedestrians can be guaranteed, something like that. I don't know whether how far it will be useful for our normal vehicular traffic, and even if it is implemented, how much it is going to cost, and our kind of a traffic conditions. So that is still a question mark.
Yes, sir. Yes, sir.
Only time can tell, can give an answer.
Yes, sir. Yes, sir. Your lecture is excellent, sir. Good. Very good.
Thank you. Thank you.
Thank you, sir. Excellent.
So,
my thanks to Chakravarti sir and Pawan Kumar sir also, and Ravi Shankar sir also, sir. Very good lecture today. We are very happy.
thank you, sir. Any more participants?
Sir, good afternoon, sir.
Yeah, please tell me.
Sir. Sir, about Vism software, sir. Sir, can we use the software for knowing the change in traffic capacity because of usage because of bus stops and all? Any such type of application?
So you mean to say when bus stop is there, without bus stop, with bus stop, how the capacity of the intersection or the highway is going to change?
Yes, sir, because maybe students have done a project impact of bus stops on traffic capacity. So can we use Vism software there?
Yeah. Definitely you can use it, but only thing is you may not get the capacity as output from your from the Vism. Basically, what it gives you is the flow, the speed, and the travel times, and so that kind of information, or bus stop waiting times and all these things. But you need to calculate the capacity from those variables that from the output that you are obtaining from the Vism, and you can compare the capacities. Maybe before the comparing the capacities, better you compare the flow levels or speed levels, the average traffic speed levels without bus stop and with bus stop. Then you can go for the capacity calculations based on the data available. And even there is, if you go to the Vism website, just go to the PTV Vism Germany website. So they have some student versions are available. Like they will call it as university versions, I think. Technically, they'll call it as. They got limitations in terms of some. You can simulate up to 10 minutes, 600 seconds, and you can simulate only up to 1 kilometer, I think. These are the restrictions. These are the major restrictions, but for your work of analyzing a bus stop, that will be sufficient enough. You can do that small exercise.
I ask our students to select the stretch from this Gatke, Uppal to Gatke, sir. That stretch.
But that is like quite a very long stretch. So you need a academic version, which is a little bit costly actually. But otherwise, using a student university version within 1 kilometer, you can simulate various aspects. That is possible.
Okay, sir. Thank you so much, sir. It was a very informative and interesting session with videos and all. Thank you so much, sir.
Yeah. Yeah. Thank you.
Any more participants? I have one question. In India, normally in India, we have intersection of national highways. So when we are designing intersection and national highway,
Sir, my voice is not clear.
Normally, when two NH national highways meet each rectangularly or right angle at right angles or whatever we call it, how to design that intersection? Is there such software available to design that type of intersections? Because national highway means 6 lane. When you do a 6-lane road is meeting another 6-lane, and that intersection design, normally it is not on one plane. It will be in vertical plane and as well as horizontal plane. Any such one software is available to design this type of intersection, sir?
So are you asking about the geometrical design aspect? So if it is a geometrical design, MX Road is one best tool. We can use it without doubt. But if you are speaking MX Road, that is a Bentley system. Sir. Bentley, they have this STAD and also like they have MX Road is there. So Bentley Corporation. So and if you are speaking from the merging and diverging sections point of view, not the geometrical design. I am not saying about the geometrical aspects, but how the merging will happen and how the diverging will happen. Whether there are any other issues, then we need to use any other microscopic simulation like VSIM or something, some other.
Oh, thank you, sir.
And in the other presentation also, I was
Right,
saying
yes.
about this, sir, regarding this, when you want to study any safety aspects at the same location, for example, I want to estimate in terms of like if you take a particular geometry, whether that will be more effective in reducing the accidents or how the geometry will affect the accident number, occurrence of accidents. So for that we don't have a unified tool. I never came across anything like that.
Okay.
So we need to utilize the information from this microscopic or some other thing, and then we need to analyze it. But we don't have a unified tool where the safety aspects can be better studied. So that is.
Okay. Nice. Oh, got it. Nice. Thank you. Yeah, any more questions from
Yes.
participants? Okay. So before you close, I request our management member, Dr. Kishore Garu, our Director ISVC and Management Member, SVCET Group of Colleges, to speak few words about this session, sir. Kishore, sir.
Good evening, sir. Ravi Shanker Garu, very good evening.
Yeah, good evening.
Thank you, sir. Thank you for the wonderful light on and sharing some light on the latest technologies and the simulation softwares. I definitely think that this will be very useful. Overall, it has been a great knowledge learning experience. I'm pretty sure that it would be a great experience for all the participants. On behalf of the Institute, once again, thank you, sir, for accepting our request and enlightening us on all the latest procedures. Thank you, sir.
Thank you, sir. Thanks. So, as a token of Dr. Ravi Shanker sir has given two wonderful lectures, one on the inaugural and one today. And we are very thankful to you, sir, for sparing your time. And we expect, we request you to continue our support with few more lectures down the line. And I request you to spare your time also, sir.
Yeah, definitely, sir.
Thank you very much, sir. And
whenever you need it, you just give me a call or a message. Definitely, I would like to help you all regarding whatever is possible.
Sir, so very thank you very much, sir. Sir, thank you, sir. As a token of gratitude, I request our faculty, Pawan Kumar, present vote of thanks for today's session.
Good evening, sir. Good evening. I am very delighted to present vote of thanks. At the outset, I sincerely and wholeheartedly thank today's resource person, Dr. KVR Ravi Shanker Garu, Assistant Professor in NIT Warangal, for his valuable and informative presentation. Sir, we are very thankful to you for sparing your valuable time for us and presenting about intelligent transport system, applications of future intelligent transport system, its services, traffic management, types of traffic detectors, adaptive traffic signal control system, pre-timed control coordination, intersection geometry, case studies on integration, Hyderabad city of ITS and its road safety, pedestrian safety, and other topics. Indeed, we all are very happy and excited to listen to your presentation on covering various aspects of intelligent transport system for mobility and safety. Sir, we are very fortunate to understand intelligent transportation system for mobility and safety, and we will definitely share these ideas for society development. Sir, we profoundly thank you once again, sir. Thank you, sir.
Thank you, Ravi. Sorry. Thank you. And thank you all the participants for being present in the section. So thank you, Ravi Shankar, once again for your enlightening lecture. And a small announcement for participants. attendance form and feedback form will be posted in the WhatsApp group.
Okay,
And please fill it and submit, sir. And tomorrow is the last day for this FDP. And
yes, sir.
tomorrow's lecture is scheduled by Dr. Tejasvi, Assistant Professor at WARANGAL. He will be talking on vulnerability of structures. And that is the last session for this 1 week FDP. And I
Yes, sir.
request all the participants to join once again, but tomorrow same time, 3 o'clock sharp, we'll start the session.
Okay,
And
sir.
I thank you all once again, and I thank you, sir. Thank you all. Thank you very much. Thank you.
Thank you, sir, for everybody.
Thank you,
Thank
sir.
you, sir.
Thank you,
Namaste,
sir. Thank you, sir. Thank you. Thank you, Ravi Shankar. Thank you.
Thank you, sir.
We'll close the meeting, sir. Thank you.
Thank you, sir.
Thank you. So we'll close the meeting now. Ramkrishna garu.